This is higher homework. It's the Unit 2 extension work, and what we're doing here is we're going to be doing question 11 part C. Okay, so similar with the other questions that I've done, the A and B, what we've got is a range of 0 to 360 degrees. Generally in higher you may have to do this in radians, which you will have to do, but just now we're just doing them in degrees. And what I'm going to try and do is I'm going to solve this equation that's sitting here. Now again, if I look at that graphically, so what I would have is quite a weird graph here, and what I'd be looking for in solutions, I've got 3 cosine 2x plus sine x minus 2, and in the question it equals 0, so where y equals 0 is what I'm looking for. And that would be the roots of this graph. So there's 1 mark there, 2 there, 3 there, 4 there. So I'm looking for 4 solutions within this graph, and that's where we're going to find the roots. So remember, what we're doing is we're going to break it down into its components, simpler components, into cosine x and sine x. And what we're going to be doing is using the formulae or formulas that were given at the bottom of the formula list. Right, so what I've got here is, so different from A and B, I've got cosine 2x here. And with cosine 2x, I've got 3 choices to use here, okay? And the way I'm going to use my choice is I'm going to be looking at this term here. If that's a sine x, what I'm going to do is I'm going to use this one at the bottom here. So I get a sine squared, a sine x, I'll have a number possibly, and what that will do is that will give me a quadratic that I can then solve from there. Generally I wouldn't use this equation here in this type of work at all. All I would use is I would use the sine squared x if it's got a sine x inside, or if it's got a cosine x, what I'd use is I would use the cosine squared solution or alternative formula for that. So let's go ahead and use this formula here. So the first thing I'm going to do is I'm going to have this 3 sitting outside, and in a bracket I'm going to replace 1 minus 2 sine squared x. So all I've done is for that there, I've replaced it with 1 minus 2 sine squared x. I've got plus sine x minus 2 equals 0. So there's the equation that I'm going to be looking to solve. Right, I'm going to multiply it out first, so that's going to give me 3 minus 6 sine squared x plus sine x minus 2 equals 0. From there, what I'll do is I'll reorder it, and I'll get the square term first, the sine x next, and then the numbers gathered up after that. And what we'll get is, from here, I'll have minus 6 sine squared x, I've got plus sine x, and then I've got 3 minus 2, that'll give me a plus 1 that'll be there. So that'll be a plus 1 equals 0. So that's me got that into a trinomial form. What I'm going to do, just to make it easier for myself, I'm just going to multiply throughout by minus 1. What that will do is I'll get rid of that minus sign at the front, but it'll change all the signs as I go along. So I've got sine squared x minus sine x minus 1 equals 0. Right, so from there, just similar to what I was doing in part A and B, but this one's a bit more complex. All I'm going to do is I'm going to factorise the trinomial that's at the top here. Right, so we're not taking out a common factor, because it's not a common factor, it's a trinomial piece of work, and what we'll do is we'll put it into 2 brackets. Right, so I've got a couple of options for 6 sine squared x, but what I'll go for is I'll go for 3 sine x, and I'll go for 2 sine x. 1 is just going to be 1 and a 1, and the signs that we'll be putting in will be, one of them will be a minus, one will be a plus, so let's go for the biggest one there being the minus, so that would be minus 3 plus the 2 gives me the minus 1 that's in the middle there. Right, so here's my 2 solutions just coming out of here. So what I've got is I've got 3 sine x plus 1 equals 0, and over this side I've got 2 sine x minus 1 equals 0. So here we've got sine x is equal to, take the 1 over, it'll become a minus 1, divide it by the 3. Okay, you can take a couple of other steps if you want, but that's what we've got from there. From here, what we've got is we have sine x is going to be equal to, bring the 1 over, it'll be a positive 1, divide it by the 2 that's there. So I've got sine x equals a half. Right, so I've got two fractions that are here, so what I'd be looking at is to to use the cast table for this. So a cast table for the first one here, what I'll do is I'll just draw one here at the side. So all sine, tan and cos, or think about the graph, the sine graph itself, where it's negative. Sine is positive in the all and in the sine quadrant, it's negative down here in quadrant 3 and quadrant 4. If I look at a cast diagram for this one here, all sine, tan, cos, I know that the sine x is positive, it's positive a half, so I'll be looking for a quadrant 1 solution and a quadrant 2 solution on that side there. Right, so let's work out the acute angle first of all. So the acute angle is going to be x is equal to the inverse sine of 1 over 3, and that should give me a value of, let's get it on the calculator. So inverse sine of 1 over 3, what that will give me is 19.5. That would be to one decimal place. So it would be 19.5 degrees. So from there what I can do is I can work out where my solutions are, because this isn't a solution. I've got, let's see, so my quadrant 3 solution will give me x is equal to 180 plus 19.5. And for my quadrant 4 solution, I'll have 360 minus 19.5. Right, so this part here should give me 199.5 degrees. This one here, 340.5 degrees. So they would be my solutions coming out of this side of the equation. Looking at the right hand side here, so this is sine x is equal to a half, so I know that the acute angle here from my table of exact values is going to be equal to 30, isn't it? So that's equal to 30 degrees there. So my quadrant 2 solution, because that one there is one of my solutions, so quadrant 2 is going to give me x is equal to 180 minus 30 degrees. So what that gives me is 150 degrees on that side there. Right then, so let's just gather up the solutions together after doing that work. So the solutions are going to be, and we'll put them in order, so let's go for the first one. First one must be 30 degrees. Next one is 150 degrees from over here. Next will be 199.5 degrees, and the final one 340.5 degrees there. So let's just check that that's the same as what we've seen on the graph. So here we go, there's that kind of weird graph that we've got for that question. So we're looking at 30 degrees as the first one, it was 150 after that. The next value was just short of 200, so that would be 199.5 and 340.5, so it's just over the 340 mark there. So that's the solutions that I've gathered up for this question here. Right, let's look at marking this one. So what we'll go for is, we'll go for 1 mark for replacing the cosine 2x with the 1 minus 2 sine squared x. What we'll then get is 1 mark for getting the equation into a quadratic form, a form where we're able to factorise. So it can be either that form or that form that's there. What we'll then get is we'll get a mark for factorising. So putting it into the 2 brackets that are there, give 1 mark for that one there, and I'll give 1 mark for this line here, so that would be both of these being correct. I'll give 1 mark for getting the answers from this side, and a final mark for stating what your solutions are in total. Okay, so that's a total of, let's see, 1, 2, 3, 4, 5, 6. So that's out of 6 marks. Okay, and the last one that we're going to do is part D, and good luck if you try that before I do the solution.